Hello, it's Jimmy here again at O'Reilly's Mobile Mechanics, and we're looking at a Mercedes B-Class 1.5 diesel. So we're inside the car here. I'll start it up. It's got the engine management light on. Now, this person has had this at a garage. So in this case here, the story I've got on this is he's had it at a garage. They've replaced various sensors on this vehicle, and within a half a mile of him leaving the garage, the engine light's back on. He's gone back to the garage and they've told him to just take the car for a drive. If you drive it long enough, it will fix itself. But once you've got an engine management light on, that's not going to happen. Your engine management light's not going to really disappear on its own. Once it's triggered off that amber warning, it's not going to go away on its own. It's going to need fixing. So I'm just running a diagnostic scan at the minute. Let's see what faults we have. You might have noticed that I mentioned before, these Mercedes take forever when they're doing a diagnostic scan. It's literally like 10 minutes just to get in here. It's an extremely slow car to do diagnostic scans on. Just waiting to get in for the diagnostic system to load up there. It takes almost 10 minutes. Now, I don't know if that's an issue with this Autel machine, with the Mercedes systems, but maybe might look into buying a different machine soon in the future and try one of those out. But not really sure what the best secondary brand to go with. Looking at maybe Launch or Top Don. So let's see what these codes has got. Pause it for a minute, it's going to take a while. Okay, we just got come in now, so let's read the codes. Okay, so we've got these two codes. P145392, P200296. See if the component particle filter is not okay. The efficiency of the particle filter is inadequate. An internal component fault exists. So you've probably seen that I've worked on a few Mercedes before, and they have common issues with the differential pressure sensor and the NOx sensors. So it may be an issue with these. Let's go into the live data and see what we can see in there. We'll go back. We've got live data right here. Exhaust, yes. Diesel particle filter. Okay, we're in on the live data, so we're going to start the engine up now and see what sort of readings we're getting from stuff. Pressure in the differential. So we've got 0 right here. Exhaust pressure 1500. Let's have a look. Okay, so we're going to need to look at the differential pressure sensor. So we go just down the back of the engine over here. Let me just put the torch on. See if I can get in there. We are, you can just there. Move this pipe out of the way, this white sensor. So with this being a Renault engine, I'm sure they'll have the same common issues that most of the Renaults have, where one of the pipes here splits, and that's why you're not getting a reading from the sensor. So I'm going to see if I can get this sensor out now. It's on a little bolt here, right there where my finger is. Just get my hand out there, got that bolt. It's a little 7mm. Now I've got that bolt off, move the sensor forward. You can see there someone's been ripping out of that plug. It's been torn up a bit, and it looks like the pipes might be pretty new. So maybe someone's already replaced this. I've just made that a bit black with my fingers there. It was clean a minute ago. Right, I got that out. That was fiddly. Just gotta screw up my arm up a little bit trying to get down there, but we got it out. So that was sitting in that direction, I think. You can see there one of the sides there, one of the sensors on this side is got some carbon soot in there. So we need to figure out why it's got 0 reading on this sensor. Is the sensor broke? Are the tubes broken or blocked? So what we're going to do to figure that out is I'm going to use some of these tools. This is a Mitivac pressure gauge and a O'Toole manometer. So I'll just connect the sensor back onto the wiring harness of the car. Now I've got the Mitivac pressure gauge connected to that, and I've got the live data readings on at the same time. So if I put pressure on here, I should get pressure reading from that red 0 there. So let's raise that up. See there, it's 0. So I'm going to press this pressure gauge hose onto the DPF pipe down there. So this is the black one. I'm going to come back out and get that connected onto the pressure gauge. Okay, so that's connected up there now. Just going to see if it's holding any pressure in that within that pipe. See if it's blocked or not. It seems to be free. So it's not holding any pressure. We'll pull that out. So now onto that same pipe there, I'm going to connect the manometer and I'm going to start the engine. You can see there we've got 5 millibars of pressure. It's about normal. I'm going to use this laser pedal depressor just to accelerate it up to about 2000 RPM or 2.5. A little bit too high there. Let's pull it back a bit. It's a bit sensitive. Let's try it a little bit slower. It's really difficult to get this to stay at a standard rev. It's just continuously going up. Let's have a look at that. So it looks pretty normal. So it turns out the garage that looked at this was a bit wrong, because he said it needs the DPF removing to clean it. They did tell him to take it on a drive as long as he can, and if that doesn't work, it'll need the DPF removed to clean it. But the DPF is not blocked on this. It looks like it's just a dodgy sensor. But we're going to check the wiring harness, make sure it's got power to it. So we've got a multimeter on it there. We got 4.7 volts, which is normal. Disconnect that now. Right, so I've pulled out this hose here from where the sensor connects, and that's obviously going to be giving me a wrong reading there. So those tests I just done with the manometer, you're not going to be able to trust those, because obviously the pipe had a split in it, so it wouldn't be giving you the full reading. So we'll now see if I can connect the manometer back up and see what the actual pressures are, because this was a split pipe here. Now we're going to see if we can get it connected properly and get an actual reading. Okay, so that's still reading the same, so it was giving sort of an accurate reading. So yeah, it's just the normal pretty common thing that you'd see on the Renaults with the 1.5 DCI engine. So it's the same engine. So we've got the same issue here with that sensor again. So we're going to replace the sensor and both the pipes down here. Okay, I've just disconnected that bottom one there. And yeah, I managed to do that by hand by squeezing that together and pulling that off. It's a little bit difficult to get tools down there. But we've got the sensor off now. We're going to get that plug open and we'll get it out. Now usually with these sensors, they're where they're on the tube for so long, on the metal pipe, they're really hard to pull them off. You can pull with all your strength, but they literally don't want to come off. So what I usually do is get a pick under there and work it all the way around, and it just breaks the seal. Then you can slide it off. So here we got some genuine Mercedes parts to replace them with. New sensor here, genuine Mercedes, or should I say Renault. Anyway, we're going to get this fitted and we'll get all of these together. Both new tubes there, hoses, and they'll connect it back onto the metal pipes below. Okay, so just assembled all that new sensor and the tubes there. So the green one goes on the side closest to the plug, black one this side. Now we'll just get it down and get it fitted in the engine. So that's the new sensor in there. So if you come around the back, just down there, that's where it sits there. It's just around the back of the engine there. We just have the slow process of doing the diagnostic test here on Mercedes. You often hear me complain about them. So now we're back into the diagnostic codes there. That's the code that it's got again. P145392. And if you remember, I said at the start of the video, he had it at a garage and they've apparently already changed that sensor, he's now told me. And within 100 feet of him leaving the garage, the lights come back on, and they just told him to take the car for a drive and it should fix itself. But clearly it's not going to fix itself with the hoses leaking. So we'll clear that code now. We'll go to the live data and we'll start the car up. Okay, so we're back in the live data now, and you can see there on the differential pressure sensor, before we had 0, and we've now got 5, which is perfectly normal on idle. So this car doesn't need a DPF clean, and the engine speed there, that's 850 RPM. So let's put it up to about 2,500 to 3,000 RPM and see where we're going on the differential pressure. Well, that's almost 4,000 RPM there. We're only on under 30. So yeah, them readings are perfectly normal. You can see there, accelerate up and down. Sorry, you can't really hear the engine noise. I noticed that from one of my comments on the videos earlier on one of my previous videos, because I'm wearing some of these. I'll take them off. I'm wearing these earphones here, called Aftershocks. They're just wireless earphones, and they give you this for wireless calls, and it's just easier for me to use while I'm working on an engine. But they do have noise cancelling on them, so it deadens out the background noise. Now I'm just going through the adaptions list here. So there's no values I can reset for the pressure sensor, just the DPF itself there. So we don't need to do that because it's already on 0%. So that's it. I think we're just almost about finished. Yep, that's it. We're all finished, and we'll see you on the next video.